Welcome to the DIY Honda Garage channel. The diagnostic trouble code DTC P0103 refers to a high voltage issue in the mass airflow MAF sensor circuit for the Honda HRV models from 2016 to 2022. This code indicates that the voltage reading from the MAF sensor exceeds the threshold levels that are set in the vehicle's powertrain control module, PCM, which is responsible for monitoring various engine parameters. The MAF sensor is essential as it measures the amount of air entering the engine, allowing the PCM to calculate the correct fuel-to-air ratio, ensuring optimal engine performance. If this sensor fails or provides inaccurate readings, it can lead to inefficient combustion, potentially harming engine components and overall fuel efficiency. The MAF sensor is typically located in the intake air duct, downstream of the air filter and upstream of the throttle body. Its electrical connections must be functioning properly, as any faults in the circuit can severely impact vehicle performance. The DTC P0103 indicates that the MAF sensor is experiencing a circuit high voltage issue. The MAF sensor's role is to monitor the amount of air entering the engine and transmit this data to the PCM for proper fuel management. When the PCM receives voltage from the MAF sensor that exceeds 4.89 volts, it triggers the code. This scenario may arise from a fault in the sensor itself, a wiring issue, or poor electrical connections. The MAF sensor is typically located within the air intake system, making it susceptible to issues like contamination or wear. Identifying whether the DTC is confirmed or pending is crucial. A confirmed DTC indicates a recurring issue, whereas a pending DTC may resolve itself under different conditions. Several factors can lead to the triggering of DTC P0103. Is the possibility of a faulty MAF sensor itself. Sensors can fail due to wear, heat exposure, or contamination. Second, wiring issues such as frayed, shorted, or broken wires can disrupt the electrical signal needed for accurate readings. The third possible cause involves loose or poor connections at the MAF sensor or the PCM. Such conditions can lead to intermittent failures, making it essential to perform thorough inspections of the wiring and connectors. Additionally, results from the Honda Diagnostic System, HDS, can help pinpoint these issues more effectively. Each potential cause must be examined to ensure the root problem is addressed, thereby preventing further complications. When DTC P0103 is present, various symptoms may manifest within the vehicle. One common symptom is noticeable engine performance issues, such as rough idling or stalling, as incorrect air-fuel mixture ratios affect combustion efficiency. Another symptom is poor fuel economy, which can result from the engine running too rich or too lean due to inaccurate data from the MAF sensor. Drivers may also notice the check engine light illuminating on the dashboard, indicating a fault that requires attention. These symptoms highlight the importance of the MAF sensor in maintaining optimal engine operation and fuel efficiency, and they necessitate prompt diagnosis and repair when encountered. The first troubleshooting step involves verifying the problem by turning the vehicle to the on mode and waiting for 2 seconds. This allows the vehicle's systems, including the powertrain control module, to initialize and perform self-checks. Next, the parameters of the MAF sensor need to be reviewed using the Honda Diagnostic System, HDS. Specifically, you should check the voltage reading. If the MAF sensor voltage exceeds 4.89 volts, this confirms the issue. A yes response indicates that the conditions match the threshold set by the PCM, meaning a failure has been reproduced. Conversely, a no implies an intermittent failure, requiring additional inspection of connections and terminals. Recording snapshots during this stage can be beneficial for future reference. For the second troubleshooting step, ensure that the vehicle is turned off by placing it in the off-lock mode. After that, the SCS, Service Check Support Line, should be jumped with the HDS for over 1 minute to prepare for continuity testing. Disconnect the MAF sensor, IAT sensor, 5P connector, and the PCM connector B, which consists of 51 pins. Continuity must be checked between specific test points, from the female terminals at the MAF connector number 2 to the PCM connector B number 24. It is vital to follow the correct wiring and ensure that test conditions are met for accurate measurements. If continuity exists, the VGM, Vehicle Ground Module, wire is confirmed functioning correctly, advancing to the next troubleshooting step. In contrast, if there is no continuity, an open circuit repair is needed. The third troubleshooting step begins with reconnecting the PCM connector B before performing continuity checks again. At this stage, it is critical to ensure the vehicle is still in the off-lock mode and that the MAF sensor IAT sensor 5P connector remains disconnected. You will measure continuity between the MAF sensor connector number 2 and a body ground. A yes answer indicates that the internal circuits of the PCM are functioning correctly, leading to the next step where the MAF sensor or the IAT intake air temperature sensor must be replaced. However, if continuity is lacking, it suggests potential issues with the PCM itself or related circuits. You will need to consult authorized service information or consider substituting a known good PCM for further diagnostics. After completing the necessary repairs related to DTC P0103, it is essential to perform a final verification. This involves taking the vehicle for a test drive to ensure that everything operates smoothly. During this process, observe for any recurring DTCs that may appear after the drive cycle. Additionally, verify that all repaired components, including any replaced sensors or wiring, are functioning as intended and have resolved the issue. If no DTCs are present, the diagnostic process should be concluded positively. But if the problem persists, revisiting earlier steps in your diagnosis might be necessary. Ensuring reliability and performance in the engine's operation is the ultimate goal of this verification. To prevent the reoccurrence of DTC P0103, implementing a regimen of preventive maintenance is advisable. This should include regular inspections of the MAF sensor and its related wiring to ensure that all connections are secure and free from corrosion or dirt. Cleaning the MAF sensor periodically can also help maintain its functionality, as contaminants can build up and lead to inaccurate readings. Additionally, ensure that the air filter is clean, as a clogged filter can cause airflow issues that affect MAF sensor performance. By adopting these preventive measures, vehicle owners can help alleviate the potential for future issues related to MAF sensor performance. A proactive approach will save time and costs associated with extensive repairs. In summary, DTC P0103 is indicative of high voltage in the MAF sensor circuit, which can disrupt optimal engine performance. Effectively addressing the root of the problem requires a thorough diagnosis and repair process. The essential steps include verifying the problem, checking for wiring continuity, and assessing the PCM's internal functions. Alongside these troubleshooting measures, implementing regular maintenance practices can substantially reduce the likelihood of reoccurrence. Monitoring overall vehicle performance, including changes in fuel economy or engine responsiveness, is vital for early detection of problems. Ultimately, ensuring the MAF sensor and its associated systems are in good working order is crucial for the vehicle's performance and longevity. Please like and subscribe to the channel. See you next time.